5.5 is the second to last section in chapter 5, and we're still dealing with logarithmic equations. Now we're actually going to solve them. So in 5.3, we were introduced to what a log was. It's a way to rewrite an exponent. In 5.4, we were introduced to the properties where a product of logs changed to addition, and vice versa, and division of logs changed to subtraction, and vice versa, and the power can come down. So we learned all these properties, but in 5.5, we're actually going to use those properties to help us solve logarithmic equations. So up until now, every equation we've seen has either been a linear equation, a quadratic equation, or a polynomial equation that you've been able to factor and solve, okay? So these are like nothing you've seen before, all right? So let's look at objective 1. Solving exponential equations. It says equation with variables in the exponent. So this is something new. We have a variable in the exponent now. How do we get that x down? You can't take an xth root. There's no such thing. And so how we're going to get the x down is one of two ways. We're going to either rewrite it to a logarithmic equation, or we can rewrite it so that the bases are going to be the same, and we can use this rule down here that if you have the same base, the powers just equal to each other, what I wrote on the board over here, okay? So there's one of two ways. Can 20 be written as 3 to some power? No, because what is 3? 3 to the first is 3, 3 squared is 9, 3 cubed is 27, we jump over 20, right? So this would be one where we'd have to solve it as a logarithmic equation, okay? We'd write it as a log and see if that helped us. Here, though, can we write 64 as a power of 2? Yes. 64 is actually 2 to the 6th power, because 2 to the 3rd is 8, 2 to the 4th is 16, 2 to the 5th is 32, and 2 to the 6th. So on this one, what we would do is we'd write 2 to the 6th, so that way 5 6 just equals 6, and you just worry about the exponents, okay? So let's see what we can do. Let's jump to example 1 down here. We have 2 raised to the 3x minus 7 power equals 32. So your first go should be, can you write 32 as 2 to some power? You can. I just said it. It's 2 to the what power? 2 to what power was 64? 6, right? So what's 2 to the 5th power? 32. Say you don't know that, do your factor tree, right? Is it a bunch of 2's? And it is. So like say you're not too sure, go over here and say, okay, this is 4 times 8. 4 is 2 times 2. 8 is 2 times 4. 4 is 2 times 2. What do I get? 1, 2, 3, 4, 5 2's. So I can actually rewrite this as 2 raised to the 3x minus 7 equals 2 to the 5th. So it's just that rule number 2. It's called the base exponent property, where if the bases are the same, the only way the left can equal the right is if the exponents equal each other. So you basically can just ignore your base and just pull down the exponents and solve, all right? So what's the only way that this can equal 2 to the 5th is if the exponent equals 5, right? So we'll just take 3x minus 7 equal to 5 and solve like normal. What's your next move you're going to make? What? Add 7 over. So we'll have 3x equals 12 and then do what? And you'll get 4. All right? And so, you know, the teacher in me says, what is nice is that anytime you have an equation, you can check your answer. What we just got done doing in chapter or 5.4, there's no check. You don't know if you wrote it as a single log correctly or if you expanded it correctly. All you need to do here to check your answer is take 2, caret button, parentheses, 3 times 4 minus 7, close off your parentheses, and just see if you get 32. Okay? So every problem we do today can be checked because it's an equation. All right. B, we kind of just talked about this. Is there any way to write 20 as a base of 3? No, 3 is not even a factor of 20. So what we have to do is we have to do 2. Convert it to a logarithmic equation. So this is going way back to 5.3 where we first introduced to it. So I know I kind of do it backwards from some people, but I always say, okay, log base what? Well, what's our base in the exponential?
X.
Nope.
Wait.
3. The base is what's being raised to a power, right? So it's going to be log base 3 of what?
X. 20.
20 equals x. Remember, your exponent is the log. Your exponent is the log. all right? And you look at me, you're like, okay, now we know what x is. X is log base 3 of 20, but what's log base 3 of 20? Well, remember we learned, I'm going to flip the order here real quick. We learned in 5.3 that we can actually convert any base to any base we want using the change of base formula. And so what we can do is we can rewrite this as log of 20 over log of 3, or natural log of 20 over natural log of 3. Make sure it's what you're taking the log of, so 20 is the top. So we're going to rewrite this as log of 20 over log of 3. And then we're going to put it in our calculator like that. Just real quickly, what is 3 squared? 9. What is 3 cubed? 27. So do you agree that 20 is between 9 and 27? Mm-hmm. So our answer is between 2 and 3, right? We know it's going to be some number between 2 and 3 because when we square 3, it only gets us to 9, but when we cube 3, it gets us up to 27. So whatever you put in your calculator should be 2 point something. 2.7268. Okay, so let's do 4 decimals. So what do you get? 2.7268. Remember what we just found was the exponent to which we have to raise 3 to get 20 perfectly. So one way to check it is if you've already done your change of base formula and you have that crazy decimal, you can actually do 3 caret answer, hit enter, and hope that you get 20. So that's what we did. We found that number that goes on forever, 2.7268, blah, blah, blah. That's the exponent to which we need to raise 3 to get perfectly 20, okay? And if you're like, oh crap, I messed it up in my calculator, you can use this as an approximate, right? And if you raise 3 to this approximate answer, it should be a number approximately close to 20. It won't be 20 perfectly. All right. So on C, guys, there's a couple of steps we have to do. On C, we, again, want to get the variable there, but there's a lot going on. So notice we don't have a single exponential equation like we did in B. B was just this one single exponent equal to this constant. But what's cluttering up the left side of C? Who's kind of like in our way that we could easily get rid of?
C.
The E?
Oh.
Not the E. Yeah, letter C.
I was like,
yeah.
where's the C up there?
The 0 point.
The T.
We want to solve for T.
Also, you have to get rid of 100.
Let's get rid of that 100, right? He's in our way, but he's easily removable, right? How can I get rid of 100?
Because it's a
Oh, wait.
It's just a coefficient. Why don't I just divide both sides by 100, right? Let's do that first. So we have e raised to the 0.08t equals 25. Is that okay? At that point, we've just made it exactly like B. There's no power to which we can raise this weird number e to. E is like 2.7, blah, blah, blah. There's no power to which we raise e to that will get 25 perfectly. So we need to write it as a logarithmic equation. All right, so how I say it, and again, maybe mine's backwards. Maybe you bring that exponent down in front first and set it equal to the log. I don't care how you do it, okay? But I always write log base what? Well, what's our base in this equation?
E.
So do we ever really write log base e?
Natural log.
You put natural log. So log base e is natural log of what? The opposite side equals your exponent. Log base e, which is natural log of the opposite side, equals your exponent. The exponent should always be by itself equal to your log. Okay, so go back and look at B. The exponent was x. See how he was by himself equal to the log. And C, the exponent was 0.08t. See how he's by himself equal to the log, right? So we want to get t by itself. Divide, exactly. I'm going to rewrite it the order if that's okay. So we'll have t equals the natural log of 25 all divided by 0.08. And it's going to be a weird number, so we're going to have to round. My key thing to tell you guys, though, is when you type natural log of 25 in your calculator, make sure you close off the parenthesis, and 0.08 is not part of that, okay? Because if you don't close off the parenthesis, you're going to be taking the natural log of 25 divided by 0.08 instead of the natural log of 25 divided by 0.08, okay? There's a difference there. So you should get a 40 something, yep. So this is approximately, I'll do the squiggly brackets, 40.2359. Does that look right?
Yeah.
And again, if you still have it in your calculator to the ugly decimals, we can check it. Type 100 in your calculator, E, raised to the caret, parenthesis, 0.08 times answer, and close off your parenthesis.
In the air.
And I can double check it for your guys' stuff. So you can take 100 times E raised to the 0.08 times your T, which was that answer. Well, it's probably not going to work now if you've deleted a bunch of stuff, but we can use this number,
Yeah.
okay? So do 0.08. No, he's in the parentheses. So quote, have parentheses 0.08 times, so times 40.2359. And since you're rounding that, it's going to be not exactly 2,500, but see how it's really close?
Yeah.
Okay. So what you're going to do is just type the left side, 100, and then the E to the exponent's right here. E raised to the exponent of 0.08 times that 40.2359, right? And you hit enter, and since that was rounded, that's kind of rounded. But see how it's close to the 2,500.
Oh, yeah.
So again, we found the unknown value for T that when we multiplied it by 800ths, raised E to that power multiplied by 100, we have 2,500. So it's 40 something. Okay. Are there any questions with the exponential equation? So exponentials, ideally you should be able to do this, but this is going to be rare, okay? So ideally, if you can write one side as a base to a power and the other side is equal to that same base to a different power, you just have to worry about the bases, but that's pretty rare. So you're most likely going to see something like B or C. B, you get the exponent isolated. So 3 to the x, that exponential part's isolated, so we could just turn around and write it in the log equation. Here we had to divide it by 100 first, but then at that point it was isolated and we could write it as a logarithmic equation. Okay?
I like it.
I like it too. I don't know, I'm weird. Did you say I do like it? Yes, okay. I might win you over. Come to the logarithmic side.
It's hard.
It is hard. It's not easy by any means, but it's kind of cool once it all starts clicking together. So now what we're going to do is instead of worrying about exponential equations, we're going to be solving logarithmic equations, and those are just going to be using all the things we learned yesterday, right? So don't forget that if you have a single log like this, if you have a single log like that, you can just rewrite that in an exponential equation and solve it pretty easily. But if you have an addition, what do we know about addition of two logs? It changes to multiplication, and it gets it down to a single log that you can rewrite as an exponential, okay? So what we're going to be doing is we're going to combining the initial things we learned in 5.3, going back and forth between logs and exponentials, along with what we learned in 5.4 to condense it down to a single log, okay? So let's look at A. Oh, and again, it just kind of tells you, if at any point you can get a single log equal to the single log of the same base, then just worry about the insides equaling each other. So if you've got log base 5 of 2 equals log base 5 of x, then 2 is x, okay? Again, that's rare though. So let's look at A. Log base 3 of x equals -2. So you want to get it down to a single log on both sides if you can. So he's down to a single log. So what we have to do is anytime you have a single log equal to a constant, then you write it in exponential form. Okay, so what is the base technically? 3. What is the exponent? -2. The exponent is the log. Remember, that's what a log is. It's an exponent. So -2 equals what? X. You guys already solved for x. We just need to put it in a normal form. You can throw it in your calculator, but we already know what a -2 power means. Negative means I need to go to the bottom, right? So this is just equals 1 over 3 squared, which is just what?
1/9.
1/9. And that makes sense. what do I mean? Like a quick check. You don't have to do this. A quick check, though. Log base 3 of 3 to the negative 2. It's the rule we just did, right? I think x is 3 to the negative 2 power. So when I plug them back into my original, that's just that rule that we learned yesterday. What happens with log base 3 and 3?
They cancel.
They cancel. And you're left with negative 2, the right-hand side. So you found the right answer. Okay? 3 to the negative 2 power, but my math lab's going to want 1/9. Right, B. We don't want to deal with multiple logs. So what do? We use our rules from yesterday and take multiple logs and condense them to one log. So what's that going to turn into?
Multiplication.
Yep, okay. So we're going to have log of x times x plus 3 equals 1. I took an expanded addition of 2 logs and condensed it to 1 log where it's multiplication. You're like, okay, how does that help me? Because if we condense it to 1 log, we can write it in exponential form, okay? We can bust him out of the log, all right? So what is the base of this log since it's not written? 10, right? So this is base 10. Raised to what power? The first.
Which equals the x.
Equals the x times x plus 3. Guys, this is an equation I could have given you the first month that we were together. What do we need to do to start solving for x? Distribute. So this is 10 equals x squared plus 3x. What's my next move? Get them all to one side equal to 0. So I'm going to subtract the 10 over. So this is 0 equals x squared plus 3x minus 10. How do you solve a quadratic? Well, there's 3 ways. Can you use the square root property on this one? No. Can you factor? Yes. Or can you use the quadratic equation? Yes. Okay. So in this one, factoring, I think most of the time once you get a quadratic, it's going to be factorable. So try that first. It's quicker. It's a little bit cleaner than the quadratic formula. Am I saying you can't do the quadratic formula? No, you're more than welcome to. But what are factors of negative 10 that add up to 3?
2 and 5.
5 and 2, right? And the 5 is positive. So if your a value is 1, we can do a shortcut real quick. This is just going to be x plus 5, x minus 2. Okay? If your a value is 1, the 2 factors just turn to the 2 factors you told me, 5 and negative 2. All right, what do I do now to solve for x? What do I do to solve for x now? You set them to 0. Because think about what we have. And this is something that I think we take for granted. We just do it and we don't realize. We have a product. 2 numbers, when they multiply, equals 0. How do 2 numbers multiply to be 0? One or the other 0. So let's see where that happens. So x plus 5, when we set it equal to 0, we get what? Negative 5. And then x minus 2, when we set it equal to 0, we get positive 2. What we have to be careful of is the domain. So again, I know we don't feel the most comfortable with logarithmic functions in their graphs. But remember, they are that opposite of the exponential, and they rode the y-axis, right? Our y-axis was our vertical asymptote. So our domain was always 0 to infinity. We cannot take logs of negative numbers. Meaning, is negative 5 right off the bat out of the question? No, because we could have x plus 8 in our log. And x plus 8 would give us a positive. But notice what happens here. If x was negative 5, can we take log of negative 5?
No.
No. So that's out of the question completely. But like I said, like if this was x plus 8 and you plug negative 5 in, you're taking a log of a positive 3, so it's okay. So you have to make sure he can work in all parts of the logs. He can't work on either one of these logs. When you put negative 5 in here, we're taking a log of a negative number. Can't happen. When you put negative 5 in here, that ends up being negative 2. That's still a log of a negative number. It can't happen. So who's our winner?
2.
2.
Plus 3 is 5, and then we can multiply that.
Yeah.
It's 10.
You got it. So a lot of times this is going to happen where you'll end up with one positive, one negative, and the negative most likely won't work because it's not in the domain. All right, on C, we're going to do the exact same kind of idea where we don't want to deal with multiple logs. So what does a subtraction change to? Division, okay? So we're going to write natural log once. And now it's going to be 4x plus 6 over x plus 3. And it equals what? The natural log of x. Now this is unlike A or B. So on A and B, we had one log equal to a constant, and that's when we can convert it to an exponential equation. Well, this one is, hey, I have natural log equal to a natural log. What's the only way these two natural logs can equal each other is if the insides equal each other. So it's kind of like a version of this, but with logs, okay? So when you have one log equal to the other log and it's the same base, the only way they could be equal to each other is if the insides are equal to each other. So we're going to pull the insides out. 4x plus 6 over x plus 3 equals x. Now we saw one like this like once while we were working on inverse equations, and I know you guys weren't the most comfortable solving, but ultimately we don't want a denominator, right? So what's the opposite of dividing? Multiplying. So we just want to multiply both sides by x plus 3 to kind of just get rid of that denominator, okay? So when I multiply this side by x plus 3, what's going to happen? They're going to cancel out, right? But when I multiply this side by x plus 3, we're going to distribute ultimately, okay? So over here it's going to cancel, and you're left with 4x plus 6. Over here, what are we going to have to do? Distribute. So we'll have x squared plus 3x. Does that look okay? So now it's kind of like that midpoint we were in on part B, where we want to get everything to one side equal to 0 so we can factor. But we have two things we need to move over. When I move the 4x over, I'm going to subtract it because he's positive right now. But when I subtract him, I can subtract him from that 3x, okay? When I move the 6 over, he's positive, so I'm going to subtract him, but there's no constant, so it's just going to be a minus 6 on back, all right? So this is going to be 0 equals x squared minus x minus 6. Are there any arguments? We didn't have anyone to combine with x squared, so he stayed x squared. And then 3 minus 4x's gives us a negative x. And then 0 minus 6 is just a negative 6. And like I said, these are going to always factor for you. So what are factors of negative 6 that add up to a negative 1?
Negative 3.
Negative 3, positive 2. My a value is 1, so I can just do the shortcut. X minus 3, x plus 2. So what are my two potential answers for x?
Positive 3 and negative 2.
You got it. Positive 3 and negative 2. And don't be too quick to rule out the negative 2 just because it's negative. When you go to plug him in, he might work. We don't know. So the 3 should be fine because when you throw 3 in here, 3 times 4 is 12. 12 plus 6 is 18, so that's good. And you throw him in here, 3 plus 3 is 6. That's positive. And then 3 is 3. So that's good. So he's good for sure. Notice this is what I'm talking about. When you throw negative 2 in right here, it's just negative 2. Can you take natural log of a negative number? No, but notice if we would have checked the middle one first, we would have been okay, you know, but it has to work for all three. So
Now, what if it worked for the middle one?
it has to work for all three, okay, because x is in all three spots. So even though negative 2 works here, we can't do the left or right with a negative 2. So what is it? So what'd you say?
How would it work there, though, if it's negative?
Because negative 2 plus 3 gives you a positive 1.
Oh.
So that's what I'm saying. Sometimes when you go plug it into what you're taking the natural log of, there's enough stuff to make it positive there. But he doesn't work, so 3 is our answer. And again, you can check this. Like in your calculator, take the natural log parentheses 4 times 3 plus 6 into your parenthesis, minus the natural log of 3 plus 3 in your parenthesis, hit enter. No one's like listening, I know you're writing stuff down. And then when you hit enter, it should equal what you get when you take the natural log of 3. So like natural log is a button on your calculator. You can plug it in and make the left equal the right. Same with B, guys. We can easily do log, what was it, log of 2 plus log of 5 and put it in your calculator and you hit enter and it'll be 1. Okay, because log and natural log are in our calculator already. All right, guys. So that's basically it. The last page is just some extra practice. Can we see plenty of examples? So it's just kind of the same stuff we're doing, kind of scrambled in there. How do we know what to do, that kind of thing, okay? So, oh, I'm going to stop right there because that's a good stopping point.